Okay, now let's go to another level, kind of discussing about, okay, we have discussed about some of the basic concepts of memory. Now we can go to another level discussing about, okay, how these parts are working together in something like different parts of the brain, or talking about what we call memory anatomy. As we discussed, there are different types of memories, and these types of memory are kind of related to other different parts of the brain. And to be honest, this map is, I do not see that very informative. So we know that amygdala is something like emotional responses, habits are related to a striatum, but things are much more complex. Even we realize that habits that are old compared to the habits that are new, they have different representations in the striatum. So habits that are new are mainly on the ventral part of the striatum, and habits that are old are going to be mainly on the dorsal part of the striatum. So when we talk about this, let's say, even when we talk about things like the caudate nucleus, caudate nucleus is something like this. It has something like a head, a body, and then a tail. This is close to what we have with the caudate nucleus, which is a part of the striatum, okay? When we have a habit that is pretty much new, it would activate the ventral part. But over the time, you can see that there is a shift of habit that is moving from the ventral part to the more caudal part. And when I see a patient, when I expose them to drug-related cue, and they have activations here in the caudal part, I would say, oh my goodness. It is a really old kind of habitual memory that is located here. And when we have old habitual memories that are kind of encoded in this part of the caudate nucleus, they are really harder to modulate because they are older and are much more well connected to other parts of the brain. Even we have the same issues in other psychiatric disorders. For example, in OCD, most of the time we have challenges with the kind of the caudal part or dorsal part of the striatum compared to things like anxiety that are more related to the, let's say, the ventral part. And those who are working with, let's say, kind of OCD patients compared to anxiety patients, they know that, I mean, by anxiety, I mean mainly, let's say, general anxiety disorders or phobias, those things at that level. So those kind of types of kind of anxiety-related disorders are far, I can say, easier to manage compared to the kind of OCD part. And that might be one of the reasons that, I mean, right now we know that, I mean, OCD is separated from the other anxiety kind of disorders, even in DSM-5. So that's another kind of level of discussion. But we know that these let's say, function compared to different parts of the brain maps are providing a little bit of information, but they are not really comprehensive. We know that there are different parts of the brain involved in this process. We have discussed about hippocampus as a really important hub here, but we know that amygdala plays a definitely significant role. We know that kind of other parts of the brain are involved. We have discussed about entorhinal cortex before and the role of perirenal cortex and parahippocampal cortex in terms of the gates to the entorhinal cortex and then to the hippocampus. So we discussed about those features. And this is how we have, let's say, the neocortex interacting with this part, which is the MTL. So when we talk about MTL, we talk about all these kind of items that are working together and at the end are related to different cortical parts. And we discussed about those things before in previous sessions. If you remember, we discussed about hippocampus, we discussed about the role of entorhinal cortex, we discussed about the parahippocampal gyrus that are providing information to the entorhinal cortex and from entorhinal cortex to the hippocampus. And we also discussed about the role that amygdala is playing in terms of providing information to the hippocampus from the emotional processing areas in the brain. These are the pieces that we have discussed about before in terms of mainly the peroneal cortex is involved in the what pathway, and parahippocampal cortex, which was involved in where pathway, but they are connecting basically these, let's say, I can say this is the MTL complex. So this is the MTL complex that is related to all those pathways in the cortex with these connections. And I mean, we discussed about that in terms of, okay, from the visual stimuli that we have, they would go to dorsal stream, which is about where, and then the ventral stream, which is about what, and then the what would go to the peroneal, where would go to the parahippocampal. They would get kind of merged to each other in the entorhinal cortex, and then they would go to the hippocampus. But meanwhile, amygdala is providing things related to basically why. It is related to emotions and motivations. Things related to that would go through this process to amygdala. And at the end, whatever we have in hippocampus would be related to all these aspects, whether they are salient or not, where they are represented in the cortex, I mean, where they are represented in the environment, and what. So all these things are integrated to go into the hippocampus, and we discussed about that before in the previous sessions. And this is another map of how these parts are playing a role. So we discussed about, let's say, rapid encoding of flexible association. This is what we have with episodic memory. In terms of, let's say, having MTL and neocortex interacting with each other. So that is what we had. And then when we have rigid associations, which are related to procedural memories or habitual memories, then we have cerebellum, then we have striatum. I mean, those things are going to play a role. So we do not have them without basal ganglia and cerebellum. And that is something that makes things very complex in terms of the rigidity of those associations that are making things really hard to change over time. So that these are going to be the complex parts. And then we have what we call the priming effect that is important with mainly with the neocortex. And we'll discuss what is priming and how priming is making sort of cortical representations in the next step as well. So that was the end of the third part of the session. We discussed about how different parts of the brain are involved in these memories. And this is not just one single part. We have a kind of different parts of the memory involved in this experience. And as I told you, at least right now, you need to have this understanding that, first of all, when we talk episodic memories are highly related to MTL, the hippocampus. Semantic memories are mainly neocortical, so they would be on the cortex. Procedural memories are related to basal ganglia and also related to cerebellum. So those things are going to be related to cerebellum. So at least these things are going to be well understood right now in this level for you. At least these pieces are going to be important. And then the question would be, okay, how we can, if we want to modulate them, how we can modulate those pieces. And it's also important to say that this one is, let's say, rapid. This one is going to be a slow. This one is going to be a slower. I mean, it seems that we are still just exposed to ourselves to something, so we try chocolate cake, and we like that, and then we start to feel that chocolate cake is a perfect thing to have. And then over the time, you just feel that you buy chocolate cakes, you eat chocolate cakes every day, but sometimes even it doesn't taste really good, but you still do that. So you go from, let's say, just basically impulses to things that are going to get even more compulsive. So when you get to the compulsive level, then you have kind of habitual kind of processes involved in this process. So you know that these memories are evolving over time. So sometimes we just do something one time or two times. Sometimes we do it something like kind of every week or every month. Or sometimes we get to a level that we have to do it every day. Otherwise, we feel that there is something missing in your life. And there are definitely kind of specific examples for all these things that we are talking about in eating behavior. So we have people who have a specific episodic memories with specific foods that they have experienced one time in, let's say, in a specific country that they have never experienced that before. So they have a specific episodic memory with that. But there are specific memories that are more semantic, and there are specific memories related to a specific type of foods that are going to be even getting habitual. So there are, in specific cultures, for example, in Iranian culture, rice has a sort of habitual memory. And I have seen people that when they stop eating rice, they just have a really bad feeling of not being able to do that. Even they feel that, the rice does not taste really good, but they cannot stop eating rice. And it is true for some cultures in terms of, let's say, different other types of carbohydrates or starch or, let's say, fries or things related to that. So how these things are being evolved in the process of time is going to be another interesting part of the discussion that we need to understand. If we want to talk about memories, we cannot just say that, okay, this is a memory, this is a long-term memory. We need to say, okay, at what level this memory is encoded and at what part of the brain this process is happening.